So proof, okay, of the quotient rule, which is that if f of x is equal to a division of two functions, so u of x over v of x, then f prime of x will be, so we said u prime times v minus u times v prime, and all of this over v of x squared. Okay, so this is what I'm trying to prove. That's why I put a question mark here. And let's start. Okay, so I started last time. I'm going to go right away until where we were up to. So we said that f of x is u of x over v of x. So this means that f of x plus h is u of x plus h divided by v of x plus h. So this we know. Then we know that f prime of x is equal to the limit as h approaches 0, f x plus h minus f of x over h. Okay, so this, I think you know this formula by heart by now. We've written it so many times. And if I am to replace f of x plus h by this here, I will get limit h approaches 0 of, so u x plus h over v x plus h minus u of x over v of x, and all this over h. Okay, question so far?
No, it's good.
Oh, it's all good. So let's go now. At this point, I think we went a bit further. We found the common denominator here. So the common denominator I get by multiplying here by v of x plus h, and here by v of x. Okay, that would guarantee that it's the same denominator, but of course, if I multiply the bottom, I multiply the top as well. So v x plus h on top, and here v of x on top. Let's rewrite everything now. Equals limit h approaches to 0, and so now on top I will have v of x times u x plus h minus u of x times vx plus h, and all this over the common denominator of v of x times v of x plus h, and all this over h. Is it that where we were up to last time, or did we go further?
No, we had just, like, this is perfect.
Okay, so now let's continue from where we left off last time. Okay, so here I have a fraction on top over a fraction on the bottom. Okay, so what we do is we will multiply the top fraction by the reciprocal of the bottom fraction. So I will get v of x times u x plus h, okay, minus u of x times v x plus h over vx v x plus h, and then times 1 over h. Okay, so basically like this, times 1 over h. I just flipped the bottom fraction. Okay, equals limit as h approaches 0, and now this is what I'm going to do, my little trick. Okay, so I'm going to combine the two fractions by putting the h at the bottom. So I have h times v of x times v of x plus h. That's my denominator, and my numerator I have v of x times u of x plus h, and then minus u of x times v of x plus h. And as you see, I left a big space here because I'm going to add and subtract something. Okay, so what I'm going to do is I'm going to minus u of x times v of x, and of course I'm going to re-add it right away, u of x times v of x. Okay, so I did not change anything. Any questions?
Can you repeat, please?
Get the u of x.
Okay, so you want me to repeat?
Where did you
The
get
last
the
step?
Yeah.
Okay, I'm gonna repeat the last step right away. Okay, so what did I do from here to here? Okay, so this step, you're all okay with this step?
Yes.
Okay,
Yeah.
so from here to here, the only thing I did is I multiplied the two fractions, so the bottom times the bottom, here it is. And the top, I just rewrote it, but I left some space between the two terms, and I just added and minus this term. So that doesn't change anything, right? I could still cross them out, and I'm still back to the step before. Okay, so I didn't do anything different other than adding and subtracting the same term, okay, which is similar to what we did when we had to prove the product rule.
And we always have to do that?
What do you mean always? Well, you won't have to prove the quotient rule. I mean, if you have to prove the quotient rule, that's how you do it. Yeah,
okay, okay. It's only to prove.
okay, so equals.
Sir,
Yeah.
how did you find u of x, u of x, v of x? Like, how did you know that this was the term that we were supposed to?
Yeah, good question. That's intuition. Just the same way you could ask me, how do you know when you have 1 minus cos that I should multiply by 1 plus cos to recognize sine squared? Okay, so this is it's the same idea. Okay, it's something you have to think of, but you won't be asked to do this in this course. Okay, so just for this proof, I mean, I'm just showing you how it's proven, and eventually you will see proofs and proofs. If you see a lot of proofs, at some point you're going to see that this is standard practice to look to add something and minus something. Okay, but in this course you have nothing to worry about. Maybe next semester in Cal 2, do you have maybe some proofs a bit more interesting, but by then you'll be more comfortable. Okay, you will see. So don't worry too much about coming up with this. Okay, I understand that this is a concern. Okay, how did I come up with this? True, good question. Okay, so what I'm going to do here now at this point is I'm going to group the first two terms, and I see that I could extract a v of x. See, v of x I could extract. So I have u of x plus h minus u of x, all this times v of x. Okay, so this is exactly the same as the top. Okay, because if you remultiply this here and this here, you will get back to what we had on top. Okay, and in this last two terms, I'm going to extract a negative u of x. Okay, so if I extract a negative u of x, so this becomes v of x plus h minus v of x. Are there any questions? Okay. At this point, okay, so here what I just did is just factored the first two terms, the last two terms, I took out a greatest common factor. Now, on the denominator, I will divide by h, and the numerator also, I will divide by h. So I'm dividing all this by h. I'm dividing all this by h. Okay, so I'm not changing anything. Divide by h, divide by h. Equals limit as h approaches 0, and here it goes. So on the bottom is easy. If I divide by h, so the h is cancelled, and I have v of x times v of x plus h. That's what's left of the denominator. Okay. On the numerator, I have two big terms, and each of these terms I will divide by h. So I get u of x plus h minus u of x times v of x, and all this divided by h, minus, and here I have u of x times v of x plus h minus v of x, and all this divided by h. Okay, so I divided this term by h and this term by h. I distribute the h everywhere. Okay, we're almost there. Okay, I'm just giving you a bit of time to write. And so at this point, what I'm going to do is I'm going to distribute the limits everywhere. Okay, so equals to, so limit h approaches 0 of this big fraction. So u x plus h minus u of x over h times limit h approaches 0 of v of x minus limit as h approaches 0 of u of x times limit h approaches 0 of this fraction, which is vx plus h minus v of x over h, and all this over limit h approaches 0 of vx times vx plus h. Okay, so you recognize things here. This is actually u prime, and this is actually v prime. Okay, so this is u prime of x, and this here is actually v prime of x. And so I'm pretty much done. So it's going to be equal to, so u prime of x times this will be just v of x, there's no h. So u prime of x times v of x minus, this is u of x times, this is v prime of x. And on the bottom, I have v of x times v of x, which is v of x squared. And that completes the proof. Okay, that's exactly what we wanted to show. Okay, any questions? Okay.
Good, sir, I have a question.
Yeah.
What happens, like, can you explain what happens to the denominator?
The denominator?
Yeah.
Sure, I replace the h by 0.
Oh, okay, yeah. Okay, I see now.
So it's vx and vx.
Thank you.
Okay, so that's it for the quotient rule. Okay, you need to practice, but we're going to get a lot of practice. Okay, don't worry. So let me go now to the chain rule, which is a bit more difficult. And that's the last rule. Okay, the chain rule tells me that if f of x is equal to u of v of x, so it's a function of a function, then how do you derive this? It's u prime of v of x times v prime of x. Okay, so let me show you how this works. Okay, so once you're comfortable on how this works, we will do some examples. Yeah, I mean, I will prove it once we do the examples so you to understand how it works. We will prove it. So here, example. Find f prime of x. Okay, so number one. F of x is 3 minus 5x2 to the power of 100. Okay, so this is the function, and I want to find the derivative. So this is how it works. F prime of x equals. So now you see that you have a function inside a function. Could you see this? So I have a function, 3 minus 5x2 to the power of 1,000. Okay, so what am I doing to the x2? What am I doing to the x? I'm squaring it, then I'm multiplying by minus 5, then I'm adding 3, and then I'm powering 100. Okay, so I'm going to consider the inside here as the interior function, as the v of x. That's the v of x. Okay, and the outer function is the power 100. Okay, so the first thing I will do is I will derive the outer function. Okay, so how do we find the derivative of power 100? It's 100 times whatever's there, power 99. Right, this we know. Okay, so this is 3 minus 5x2. That's the first step. But I have to multiply by the derivative of what's inside. So I have to multiply by what's inside, 3 minus 5x2 prime. Okay, and that is 1,000 times 3 minus 5x2 power of 99 times, and now this I know how to do, negative 10x. And that's my answer. Any questions?
No.
Okay, so let me do another one. Okay, I'm going to do another one, and then you'll start doing a few. So number 2, f of x is equal to the square root of x3 plus x. Okay, could anybody try to guide me through it? Is there any volunteer? Okay, nobody? Yeah?
Yeah, I think like we have to do the first one, derivative of the first one is half
Very good.
1
Times
yeah,
what?
times x3 plus x
Power of what?
minus a half
Very nice. Times?
times 3x power 2.
Okay, so I'm not gonna skip this step for now, but I understand what you're doing.
Mhm.
I'm gonna do this first, okay?
Okay.
And And so now I know that I have a derivative to find here. So I'm going to rewrite this because this is finished. Times what? So what here?
3x power 2
Yeah,
plus 1.
very nice. Any question?
Yes, sir. I have a question.
Yeah.
I forgot why, but how come on the previous answer the 3 becomes a 0, but
It's a
on the
constant.
next answer, because it's a constant?
Yeah, when it's a number alone, a constant alone, the derivative is always 0.
What's like the logic behind that?
The logic, okay, good. So I'm going to do it right here, okay. So 3 is the same thing as 3 times x power 0, right?
Okay.
So if you do the derivative of this, so 3 times x power 0 prime will be 3 times, so you put the 0 in front, times x power 0 minus 1.
Okay, I see.
And that is equal to 0.
All right, thanks, sir.
Okay, good. Okay, so you see, ask every question. You have to ask questions. Hopefully, you'll ask a question that I will not be able to answer eventually. So I'm waiting for that one. Okay, so let's go. Let's try another one. So you try this one, okay, on your own. So the first thing we do here is we rewrite it in exponential form. So it's 1 minus x to the power of negative 10. Okay, once we have this, now I could do the chain rule and power rule as we did. Sorry. Okay, so it's equal to negative 10, 1 minus x to minus 11 times negative 1. Right, times the derivative of the inside, which is negative 1. Okay, I skipped a step here. I did the negative 1, which is the derivative of the inside, right, of 1 minus x. Do you understand what I just did?
Yeah.
Yes.
Okay, well, let's go. Try one now.
Yeah.
So the first thing I'm going to do is I'm going to write it in exponential form. So it's 2x minus 1 to the power of what? What is it?
Minus 1 over 3.
Very nice. Minus 1 over 3. Okay, so f prime of x will be, so I'm going to put minus 1/3 in front. 2x minus 1, then minus 1 from the exponent is minus 4/3 times the derivative of the inside, which is 2x minus 1. Okay, so I'm going to do the extra step now, prime. Okay, and so I have negative 1/3, 2x minus 1 to the power of negative 4/3 times 2. That's it. Okay, you could, of course, you could simplify, put the 2 times minus 1/3 to right. Okay, but for now, I'm not asking to simplify it. Okay, any questions? Okay, so if there's no questions, we could go ahead and try to prove it. Okay, and then after the proof, I'll go to some more difficult ones. Proof. Okay, so of the chain rule, which means that if f of x is equal to u of v of x, then f prime of x is equal to u prime of v of x times z prime of x. This is what I want to prove. Okay, so let's go for it. So just like before, f of x is u of v of x. So f of x plus h is what? What's f of x plus h? So u of v of x plus h. Yes, you're good? You with me?
Yes.
Okay, so let's go now. F prime of x is equal to the limit as h approaches 0, f of x plus h minus f of x over h. And that is equal to the limit as h approaches 0. So f of x plus h, which is u of v of x plus h minus v of x. All this, sorry, minus u of v of x, sorry, u of v of x, all this over h. Okay, so now I'm going to do something weird again. Limit as h approaches 0, and I want to do u of v of x plus h minus u of v of x. Okay. And instead of putting over h here, I will go put the over h here. And I'm going to multiply and divide by the same thing. Okay, so I'm cheating a little bit here because I'm expecting to have a v prime of x here. So if I want this to become a v prime of x, I should here have on top v of x plus h minus v of x. You see, this expression as h approaches 0 is exactly equal to v prime. Okay, so since I multiplied on top here, I have to multiply the bottom as well. So v of x plus h minus v of x. So how are we doing so far? Okay, so this is the key trick in the proof is multiplying and dividing by this. Okay. Now, sure, no questions at this point? Would you like me to slow down a bit?
It's okay.
No,
It's okay, anybody?
Yeah, actually, sir, can you just slow down a bit, please?
Thank you. Okay, very good. Okay. So this is what I'm going to do now. Okay, I'm going to let I'm going to write v of x plus h minus v of x. I'm going to call this k. Okay, so I'm going to call this K. And I'm going to notice something. As H approaches 0, K also approaches 0, obviously. Because if H is very, very small, then this difference here will be almost V of X minus V of X, which is almost going to be 0 as well. Okay, so the smaller the H, the smaller the K. You guys okay with this?
Yeah.
Shall I repeat this?
No, I think it's okay.
It's okay, anybody? Okay. So let's rewrite everything here. So my limit will be what? I will have here U of, so V of X plus H is left. So from here, I understand that V of X plus H is actually equal, if I send V of X on the other side, it's equal to V of X plus K. Is that okay? So here, instead of writing V of X plus H, I could write V of X plus K. I want to write it. V of X plus K minus U of V of X divided by, and now this, the bottom is K, times, and here I'm going to have V X plus H minus V of X over H. Okay, so all this when H and K are approaching 0. Okay, so here there's no H anymore. It's all in terms of K. So I'm going to do the limit as K approaches 0, and here limit as H approaches 0. Okay, so this term is pretty straightforward. This is equal to V prime of X. And this is what? Well, U of something plus K minus U of that thing over K. Well, that seems, this looks like a derivative as well. So this is equal to U prime of, well, of this here, which is V of X. And that's it, I'm done. That's what I needed to prove. Any questions? So this proof is a little more difficult, okay? Because this little part here, this part, the purple part here is a bit tricky, okay? Noticing that when H approaches 0, K is approaching 0, I got rid of the H here, I made the limit K. So this is a bit, it's a bit much for Cal 1, but listen, I have to prove it to you, and I think you can understand it, okay? Anyways, you look at it at home slowly after, and you'll see it makes sense. Okay, if you have questions, I'm always here. Okay, so this is proven. We just showed just like what we have, what we wanted to show on top. Okay, so as you see, it's exactly what we have here. U prime V of X times V prime, U prime V of X times V prime. Okay, let's do a few more examples. Okay, so we did up to 4, so let's do on 5. So I want to make things a bit more difficult for you guys now. So first one, let's say f of x is equal to 7x3 plus 1 power 6 times 1 minus x power 9. Would you like to try it? Or you
Yeah.
want me to do this one? Yeah, you want to try it?
Yeah, can we just try it?
Okay, so but be very careful, right? There is a multiplication here. And when there's a multiplication, what do you have to use? You have to use the product rule, right? Don't forget. Product rule. U prime V plus UV prime. And then to find U prime, you'll do the chain rule. Then to find V prime, you'll do the chain rule. Okay, so there's product and chain rule here involved. Okay, so go for it. Okay. So there's a product rule here. So f prime of x is equal to, so 7x3 plus 1 power 6 times 1 minus x power 9. So this is u prime. So this is u prime plus 7x3 plus 1 power 6 times 1 minus x power 9 prime. Okay, do you understand what I just did? Okay, so this comes from the product rule. That's what I did here. U prime V plus UV prime. Okay? And now I have just two derivatives to find. Okay, 1 and 2. This, it's finished. This is not light anymore. These are the two light ones that I have to take care of. So, equals, so the derivative of this is 6 times 7x3 plus 1 power 5 times, don't forget the chain rule, the derivative on the inside. 7x3 plus 1 prime. And this stays, plus this stays, times, and again, chain rule. 9 times 1 minus x power 8 times 1 minus x, which is the inside prime. Okay, and so now I have two more derivatives to evaluate. This and this, which are pretty easy ones now. So it's equal to 6 times 7x3 plus 1 power 5 times, this will be 21x2 times 1 minus x power 9 plus 7x cubed plus 1 power 6 times 9 times 1 minus x power 8 times, and this is -1, and that's it. I'm done. Okay, unless I ask you to simplify. Okay, so we could simplify it here if you want. Let's simplify it. So this is 126 x2 7x3 plus 1 power 5 times 1 minus x to the 9, then minus 9 times 7x cubed plus 1 power 6 times 1 minus x to the 8. And that's it. Simplified. Okay, maybe I could go further and factor out. I could extract a probably a 9, because 126 could be divided by 9. So 9, a 7x3 plus 1 power 5, and a 1 minus x power 8 I could extract, but it's okay for now. Okay, I'm not going to focus on the algebra yet. Okay, I just want to make sure you know how to find derivatives for now.
Can you re-explain, like, quickly what you did after the product rule?
Sure. So this step here, this step.
Yes.
Yeah. The only thing I did is so this I rewrote. You see, 1 minus x to the 9 I rewrote, and this I rewrote. Okay, so these two didn't change. But this one, so this is like a new problem. Okay, so this, let me hide this. Okay, so this here, this is like a new problem. Okay, I'm talking about this. Okay, so how do we derive this? Very simple. So 6 times 7x3 plus 1 power 5, and then times the derivative of the interior, which is just this. You understand?
Yes.
And then the derivative of this, I do it after, it's 21x. Okay, so basically, if I were to represent this is equal to that here, and now this one is equal to it.
And the rest, you just leave it there?
So the rest, whatever is not in red, whatever, there's no derivative involved, I will need, right? So these ones, this one and this one I will need. And then for the last one here, same idea. Okay, so this, when I do the derivative, I get that times the derivative of the inside, and the derivative of the inside is -1. Is it clear? Anybody else questions? Okay, so let me give you another one. So f of x is equal to x2 plus 1 to the power of 5 over x4 plus 1 to the power of 8. Okay, so here we have a division, so we're dealing with a quotient rule. So f prime will be, so the derivative of the top times the bottom minus the top times the derivative of the bottom. Okay, divided by the bottom squared, so x4 plus 1 power 8 squared. Okay, so do you understand the structure, what I just wrote here? Okay.
Yes.
Okay, good. So, right, u prime v minus uv prime over v squared. And now I just have two little problems to do, this one and this one. All the rest I recopy. Okay, so equals 2. So the derivative of x2 plus 1 power 5, that's a chain rule. So it's 5 times x2 plus 1 power 4 times the derivative of the inside. So it's like this, prime. Okay, so this here is the derivative of this guy times this, because this doesn't disappear, minus, and then here x2 plus 1 power 5 stays, times, and the derivative of this term, which is 8 times x4 plus 1 power 7 times the derivative of the inside, x4 plus 1 prime. And all this over the bottom squared, which is x4 plus 1 to the power of 16. Okay, any questions? That's it. So now I have to recopy everything and just evaluate these two easy derivatives. So equals 5 times x2 plus 1 power 4 times, this is 2x, times x4 plus 1 to the 8 minus x2 plus 1 to the 5 times 8 times x4 plus 1 power 7 and times 4x cubed. Over x4 plus 1 to the power of 16, and that's my answer. Okay, so the derivative of this function is this here. Any questions? Okay, let's do one more. Number 7. So let's say f of x is equal to square root of x minus 4x plus 5 power 12. F prime. So what do I do first? I put 1/2 in front. 1/2 times all this to the power of negative 1/2, right? X times x minus 4x plus 5 to the 12. Okay, so times, of course, whatever is inside the derivative. So x minus 4x plus 5 power 12, all this. Right. Is this okay? The regular chain rule. Okay, so at this point, so don't get impressed by the complexity of the expression. This is finished. This, I'm just going to rewrite all the way till the end. So this is what's important for me. It's like a new problem now, and I'm trying to find this. Okay, so let's go 1/2. I'm going to rewrite x minus 4x plus 5 to the 12, to the power of negative 1/2 times, and now I'm going to derive here. So how do I derive? The derivative of x is 1 minus, and the derivative of this is 12 times 4x plus 5 power 11 times the derivative of the inside. Okay, so it might get confusing with the brackets. Okay, because this is a sum of two functions, right? Or a subtraction of two functions, and we derive the first and derive the second. Okay, so derivative of x is 1, and derivative of this guy is this thing here. I need to do the chain rule again. So that's the last piece that I'm missing. 1/2 x minus in brackets 4x plus 5 power 12 times negative 1/2 times 1 minus 12 times 4x plus 5 power 11 times, and this is just 4, and that's my answer.